Hello, my name is Rosemary Wang. I'm a developer advocate at HashiCorp. And today we're going to talk about collaboration practices for network infrastructure as code with HashiCorp Terraform Cloud. So you might have started to write infrastructure as code, or you've started to automate some of your automation for network infrastructure. And you've adopted this idea of, okay, I'm going to try to use infrastructure as code to do it. And you share it with your team thinking, this is great, this is awesome. I can finally create this network all through maybe one command of Terraform apply. But then you realize that you have to scale this, right? It has to be shared with your team. It has to be shared with your organization. And more importantly, you have to be able to collaborate on this over time. So how do you standardize on your network infrastructure as code? We're going to answer that in a set of 3 practices today. The 3 practices include modularization, testing, and verification. These are all 3 important practices. I would say the most important practices. There are probably many more, but these are the 3 most important practices when it comes to collaboration of network infrastructure as code. Modularization means that you can group resources with common goals or common objectives, and that has the ability for you to offer self-service to create said resources. You can also test, which means validating the system functions as intended. That's a whole difficult concept to grasp, especially when it comes to infrastructure. Previously, we had a very difficult time testing infrastructure reliably and with some confidence that things did work. Verification is important because more and more we're trying to understand how we should secure our networks as well as other devices and infrastructure. Verification means checking that you have the secure and compliant configurations and settings. So we'll start with modularization. Modularization is grouping common resources to enable self-service of configured network infrastructure. And grouping common resources is a difficult task, right? How do you know which resources to group, and how do you know how many resources is too many to group together? Well, the idea is that the answer is if someone shouldn't know about these resources, you should probably group them together. So a good example of this is maybe I just need to create the security groups for Cisco ACI. I don't need to necessarily know how to create VERFs and application profiles and tenants. Maybe that's worth grouping together in a module, and someone can self-serve and get that in place, and then they can create the security groups. The modularization is a difficult task to figure out, but over time, as you practice on network infrastructure, or generally infrastructure as code, you get a better sense of what resources are commonly grouped together. So there's a couple ways in Terraform that you can group group resources for modules. This is an example Terraform module for networking that I have. This example Terraform module is something I wrote myself. Anybody can write a module, and anybody can distribute the module on the Terraform module registry. So again, use at your own risk as you look at the registry. But if you just don't want to know about how to set up, let's say, an AWS network, because an AWS network has a million components to it, and if you're a developer who does not know about what route tables do, or NAT gateways for that matter, you might not necessarily want to get into the details. So it's much easier to say, I'll use a module that has all of this configured for me, so I don't have to worry about it. All I get are these subnets at the end of the day, and I get that information. So anybody can create the module. I've created my own module, and I've put it into version control. And the reason why it's nice to put it in version control is that, well, that way you can make updates to it later on. Your teammate can update it later on. You can evaluate audit what changes have been made to it. You can also version it. Modules are very similar to sort of software libraries, right? You do want to add version tags. You want to treat it as if it is a piece of software or a software artifact. So it is useful to have the ability to push it to version control and maintain it over there. The next thing that you could also do is, well, you could also share it to the Terraform module registry. So if, let's say, you have an internal organization module set that you expect someone to use, this could be something like a network configuration that is only specific to your organization. You don't want to use the one that's out there publicly. You want to use the one that is specific to how you've configured your networks and how you've organized all of your infrastructure. Well, you can use something called the private module registry in Terraform Cloud. So I'll connect up my version control repository with all of the module and resources captured together. Terraform Cloud will pick it up as long as you have Terraform-provider the name. So it must have a specific structure to it in terms of the repository name for the Terraform Cloud private registry to pick it up. But once you've got that, then you can create the module for someone else to use. And that becomes a little bit more important when you're sharing modules across multiple teams, right? You want to be able to say, here's a network module that is compliant, that's secure, that I know that works because we've put all the time and effort to building it, and you can use it to create a network for yourself. So this is that self-service component. The nice part about a private registry is that the private registry will have all of this information. These are all docs, but we'll have information on how to use it, and you can scope what access someone has to these specific modules. So let's say you have a developer who doesn't need access to a network module. You have a different team, a platform team that needs access to it. You could change who has access to what in the registry. Alternatively, if you do, well, not alternatively, but if you do want to use the module itself, what you'll have to do is in your Terraform code, you will have to declare this module configuration block. This module configuration block takes in a source, which is where the module is located. It also takes the version. Again, treating your modules like a software artifact, really kind of great way to make sure that you're not going to introduce a new change to a module and break everybody else's code. So what you'll do is you'll declare the module configuration block and you'll have variables defined. So in this case, I have a network module and I have 3 main attributes: the region, main project tag, as well as the network CIDR that's associated with it. So anything that I want to specify, I can pass in there. I can also pass optional variables as well. It's not like every variable in a module has to be required. You can set defaults. You can set some logic in there that might validate what the defaults might be. So there's a lot of options for you in terms of developing a module. But the syntax is pretty much similar to all of Terraform configuration. You could have a Terraform configuration that you ultimately say, well, I repeat this 3 times. Let me just refactor it into a module, and it's the same syntax. Alternatively, you can use the Terraform registry that is public, right? These are all publicly available modules that someone else has developed. So for example, I'm referencing a module that I created to deploy some security tool onto my network. And in this case, I will define it as a source to the public registry as well as the version. So you can do the private registry or you can do the public registry. And if you don't want to use the Terraform Cloud registry, module registry, whether it be private or public, what you could do instead is you can refer to a Git repo, you could refer to a bucket somewhere, or object store somewhere, wherever you want to retrieve that artifact from, you can define it in source and it will retrieve it. So you are not limited to the Terraform Cloud private registry, private module registry, and you're not just limited to the Terraform registry with the public modules. You can define it through Git or some other kind of store. So here I have a public one, but again, you can choose, you can even go to the source code, the original source code, and you can update it yourself and then point to your source code if you want, if you don't like how a module is configured. There we go. So if you have more questions on the modules, you can search on the registry. For example, here we have a bunch of Palo Alto modules. If you are interested in a specific vendor, target, device, etc., you can give it a search and see if someone's created a module for it. Modules are dependent on whether or not the provider exists, right? But the modules themselves, right, are an easier way for you to self-serve or to group common resources without necessarily needing the knowledge or the sort of expertise in how those resources are grouped and configured. So it's a great way to at least try to segment out some of your infrastructure configuration and share it to folks, whether it be other teams or within, even across teams or even across companies too. If you have customers as well, some customers are usually asking like, hey, do you have a Terraform module to configure your device or your tool or something like that? Then sometimes there's an opportunity there for folks to self-serve and create their own.
if you're using a public module like that, but you do need to fork it, as you mentioned, for some internal differences, what are the best practices here to keep an eye on what might change in the future on the public one that may or may not be applicable to the fork you made locally?
Yeah, so with modules, it goes with the practices are very similar to any other open source fork or a fork in general that you might be maintaining. Certainly, you want to monitor the original repository that the module is coming from. Oftentimes, there will be some release notifications as well as notifications about new tags being added, et cetera, that you'll want to keep track of. And that will help you reconcile anything between your fork and the repository, the original repository. The other important thing to consider is if you can contribute back to the original module. Now, some things you might not be able to do at all, but there may be some logic that is useful that maybe other people might find. It's a lot easier to contribute back to the original module that's out there. Other times, however, there's such a divergence between the original module that's out there and then your fork that you end up saying, I'm just going to create my own module. And you might just create that module in your own private registry and maintain it separately. So it is sometimes the common pattern that I see where someone will take the public module that's out there, but there's some requirements in there they don't necessarily agree with, whether it be from a compliance standpoint or functional standpoint. And what they'll do is they'll fork it and pretty much copy it into a private registry for with some custom use. And that way, that's how they maintain it. They don't plan on going back to, let's say, the original module. They have a very specific way they want it to be pinned, the specific versions that they want pinned, specific configurations they plan on preserving for quite some time. And in that case, they do pretty much diverge entirely, and then they just keep their own version. They never refer back to Trump.
Mm-hmm. Yeah, well, our networking folks tend to create unicorns.
Yeah, it does happen. It does happen. It's hard to say. It's very hard to justify saying like, oh, I'll just create something, I'll just use whatever's out there right now. But it is important to as part of the sharing process. Part of the problem has been that it's bespoke configurations break systems. So it's better sometimes to have some standardization, just so that you have stable automation, because automation is predicated on having consistency. And if you have bespoke custom configurations and things, it gets a lot harder to make those changes. So it's a hard thing to advocate for, but once you see the value, it's hard to go back. Okay, testing. We'll talk about testing. This is something that's near and dear to me, but testing is about validating system functions as intended. It's difficult to test the network. I'm just going to capture that one in one sentence. In a previous life, I did test MPLS core networks, and that was terrible. It was scary. It was really scary for me. So I just, I take testing. I want to be testing my infrastructure. And the reason why is that it offers the ability for you to have some confidence in rolling out a change. It's hard to say that a change will work, right? If you, in the abstract, a change might work, a change to your system might work, but in reality, we all know it doesn't quite work the way we always think it will. So testing is really critical, especially from a networking standpoint, but also just in general for the infrastructure system. Now, Terraform doesn't have sort of like what you would say a testing library, fully a testing library, but there are components that you can put together and apply it to a testing strategy for network infrastructure as code. There are a couple of more simplistic tests that you can run in that there are along the lines of validation. So for example, there's variable validation. Maybe you have a resource or you have a module available and you only want to configure it in the United States, right? There could be GDPR requirements or something else, but you want to restrict how developers configure it. In this case, you can use something called validation, and validation is a little block that you put in variables in a variable declaration that says, okay, here's the condition. I want you to check this. And if it doesn't match, then throw it an error message saying, you can only use AWS regions in the US. So this is one example of how you do variable validation. Other folks have used variable validation for, let's say, CIDR subnet checking. They've used variable validation for IDs that are specific to their organization. Different approaches there.
On the condition, you have starts with, that's a real easy string parse to wrap your head around. But what else is available there? Any type of regular expressions, or how can you match?
Yeah, so there's a Terraform function that is for regular expressions. There's a whole list of string functions that you can use. So if you have a regular expression, you can use the, I don't even remember the correct function, but it is a regular, I think a regex function. I don't entirely remember there, but it's a Terraform string function that does search for regular expressions. You could do more complicated collection of logic as well. So let's say you have a collection or you're taking in a list of strings. You can also do some logic on that as well. The condition here, however, the condition statement is limited to the variable that you're testing, right? So you can't introduce another variable in there. So if, let's say, I wanted to check my peered VPC region, if I want to say, I want to check my peered VPC region is also US because I don't want to be subject to certain things, then I can't do that condition check here. It's only scoped to the variable that I'm validating. Right. And so the other test that you could write, and the example that I had before, which was, let's say, the region, and then I want to test the peer VPC region. If I wanted to do a more complex test where I wanted to say, okay, is this region different than the peered VPC region or peered network region that I'm interested in? You can do a test in Sentinel. So Terraform has a policy framework called Sentinel, which checks for attributes in Terraform. I like using it for testing. I still consider it testing because what you're doing is you're using Sentinel to check for specific attributes. So in this case, I have a test in Sentinel that says, check that the AWS subnets have correct mask, because if anybody has tried to use these, try to calculate subnets correctly, sometimes there's, you can't do it off the top of your head. Some people can. I can't. I have lost the ability to do that now. So it's a lot easier for me to just double check that whatever I expect my CIDR block to be, my subnet to be, I have the correct mask that I'm expecting. So this test is to say, okay, I want a /24 here. Make sure that my logic is correct, that I have correctly calculated a /24 in that subnet. So a little look on what that might be. Let's say in this case, I have a subnet, right? I have two sets of subnets. One set is for public, one set is for private. And here I have a CIDR block definition that refers to a local variable. And the local variable is using a CIDR subnet function that's native to Terraform. So Terraform offers a bunch of logical functions, as I mentioned before. And one of them includes some of these network-related ones. So here I'm going to subdivide my network, and I don't know if I did it correctly, right? Even if you're sort of on the development side of your organization, you might be like, I don't know how to divide it all correctly, and quite frankly, I don't really want to do the math, but I need to know at least to a certain degree how many I need to divide into. Well, on a Terraform apply, what you'll find is that there's a Sentinel mock. And these are sort of fixtures. There are testing fixtures for you to try to create your test, right? So these fixtures are plans. They're Terraform plans. They're just extracted and then put into JSON form. And these plans are a way for you to parse out specific values that you don't otherwise know. So while my Terraform might say, okay, I'm going to use the CIDR subnet function and then create my network, I don't actually know what the resulting CIDR block might be. So what I can do is that after I run the plan, I can download what is called a mock, or these testing fixtures, and I can check the metadata and say, okay, is this the CIDR block that I expect to see? And in this case here, maybe I've got 10.255.2/24. Because I'm able to extract this metadata from state, remember, we've got a source of truth in the form of Terraform state. I can parse this state and understand whether or not these values are correct. You can use any kind of testing framework you want. Someone asked me once, can I use Python? Yes, you can use Python. Can you use some other language to do some testing? Yes, you can. Really what you're trying to do is retrieve information from that JSON response from Terraform anyway, so you can use any language. But because it's a little bit easier to describe and to run, I'm just going to use Sentinel. Sentinel, I have some rules that says check that the AWS VPCs have correct mask, check that the AWS subnets have correct mask. So my VPC should be a /20, my subnet should be /24. I'm going to run these rules, and both of them should pass in order for my structure configuration correct, right? So the idea is I'm using these as tests within Terraform Cloud in order to check that I have configured something properly. You might be asking, like, where can I check the function of the network? Like that the network actually works the way I expect it to. We're going to get to that. This is really what we're really doing here is checking for specific configurations. It becomes more important when you do some complicated logic. If you have like collections or maps that you're trying to manipulate, sometimes it's really hard to debug or understand whether or not you've manipulated those lists or maps correctly. So it's easier to use Sentinel or a testing framework to check that those values are what you logically expect them to be. So here I'm doing a little bit of refactor, and you'll notice that I can copy this thing, this policy or this test, and I'll put it into what is called the Sentinel Playground. Shout out. Sometimes you don't even need to run Terraform Cloud in order to check that your test works as expected. So Sentinel Playground is a way for you to use the Sentinel framework without necessarily running Terraform Cloud. You can drop your test into Sentinel Playground as well as the mock that you would like to test against. Please do redact anything important in your mock before you put it on here, just as a good practice. But if you have any JSON, the Terraform JSON outputs that you want to test, double check things work the way they expect, you could drop that into the mock and under this plan here. And what this will do is it will run Sentinel and let you know whether or not your test is logically sound. So if maybe there's some syntax issues, like you wrote your Sentinel test wrong or something, then here it will tell you, please update your test to do this. But here it evaluates the rule, and the rule says, okay, do the VPCs have correct mask? Value true based on this JSON. So this JSON is telling me that I have correctly configured my network. And after I've tried it out on Sentinel Playground, then I can copy this policy or this test knowing that it is actually accurate and it will properly run on Terraform Cloud. And I could copy it into Terraform Cloud and run it. So what that will look like is, let's see, scroll down. I think we skipped this. So what that will look like is something like, why you don't do autoplay. What this will look like instead is, in my code, because I do everything as code, in my code, I'll say these are my unit tests. I'll push them into a repository somewhere. And I can configure Terraform Cloud to reference these tests. The reason why this is interesting is that let's say you have multiple people in your organization who plan on configuring networks and they want to be able to run these tests, right, to make sure that they configured it correctly. You can share these tests across your teams and around your organization. So here I'm going to apply it to a specific workspace, in this case, my cloud workspace, and I'm going to test against that workspace, right? You could apply it to all of the workspaces in an organization, and in which case that will run this test by default, right? So you could do that, but what I want to do is I want to scope it to a specific workspace, because maybe I don't want everybody running this test on every workspace. The test doesn't apply to every workspace, right? So I'll run this, and there's now a new step in the workspace. The step says Sentinel policies pending. As I mentioned before, Sentinel is typically a policy framework. I just use it for testing because it's easier. And what I do is I'm running the plan, and what happens after that is Terraform Cloud will run Sentinel after that on the existing plan. So if, let's say, someone changed the configuration, they said, all right, I'm going to subdivide my site or subnet in, and now I want /28s, well, this test will fail because it's looking for /24s. So it's something that you have to maintain over time as you do tests with other tests. You do want it to be extensible enough for other people to use it. But in this case, maybe you just want to be really prescriptive about, how you're going to set up your networking. So there's a couple pieces here, but after the plan runs and it finishes, it will. I'm going to scroll through this. You'll notice that there's a policy set called unit tests that I've added, and it has passed. So this means that I can proceed forward to apply. Why is this important? Well, let's say you started to run the apply and you started to configure the network. Well, you're only going to find out that you configured it incorrectly about 10 minutes later. So it's nice to have this unit testing approach early on. And the reason why is that it allows you to get faster feedback on any logic that you've done in Terraform itself or your infrastructure as code that isn't functional, right? It's not related to the network and how it functions. It's related to how you've configured it in the first place. So if you would like to learn more, there's the Sentinel Playground here. The Sentinel Playground is mostly, again, policy, but I like using it for testing. Now, you're asking the question, how do you functionally test? Meaning, how do I know that my network is configured correctly end to end? Unfortunately, there's not a great way to do this. There are some mocking or local testing sandboxes, or just testing sandboxes in general for network devices, networking overall. And you can now use those sandboxes. They're great. But sometimes you just don't have a sandbox available to you. Instead, the best you have is to create a network and see if it works, right? And the way we used to do this was to take forever to put something, usually a server, on that network and check that we've routed it, that it's routing correctly. That's a very primitive way of doing it, but it was probably the really only reliable way that we tested routing in our network when predating sandboxes, right? So here, what I'll do is create the network. And when I create the network, in this case, it's in AWS, I'm going to output a set of variables. So you'll notice this output test variables. This will create important variables that my test will need in order to run. So what I'm going to do is create a server on this network and just make sure that I can access it the way I expect to access it. So these test variables are important to pass along. You could do it in a couple different ways. If you have multiple Terraform workspaces set up, you could pass these variables between the workspaces and set up like a test workspace for yourself. I'm going to show sort of the non-Terraform Cloud approach, which basically says, I'm just going to run Terraform locally and do a really quick spot check to determine if this network works. We're progressing along the journey, but in the early part of the journey, you might choose not to do completely automated tests. You might choose to do some spot checking of your configuration, in which case this is a valid pattern for you to use. So if you continue going on, you output those into a file. Those testing variables are going to go into a file that I'll extract later. And the reason why I extract it later is from a security standpoint. I just want to isolate those two. I want to isolate the test server away from the actual production network. So here I'm going to create a test server and SSH into it. That is my test. It is very simple and very straightforward, but it's one way that I can know whether or not my network has been set up correctly. So I'm going to output the variables into a terraform.auto.tf-vars file. This is a variable file that will get automatically picked up by Terraform. And I'm going to run this test locally. I'm not going to use a remote backend for it because I pretty much just want to create the server, check that it works, and then tear it down. I don't want to keep the server around. It's not intended to be a persistent server for monitoring or anything. It's just to functionally understand whether or not the network routes the way I expect it to. So I'll take a little bit of time to create the instance, and you'll notice that in this test, it's creating 2 servers. The reason why it's creating 2 servers is that I have 2 public subnets that I have set up, and I want to make sure both of them work. So this test is actually pretty flexible in that if I create 3 subnets or I create 4 subnets, I'll create 1 instance on each subnet and double check that it all works, and then I'll tear all of them down. And once the test runs, it's going to use a provisioner just to SSH into it. You can use a provisioner. You can use an external script if you want, just to check that it can access the server correctly. You can use the HTTP data source to retrieve something from an API that's on the server. There are many, many options for you to test your server and to make sure that the connectivity works. The idea is that you want to scope it to what makes most sense from what you expect to be the end-to-end function to be like. So if you have a server with an application on it, maybe check that the port is open with sort of a connectivity check there. So that's one more straightforward way to do the spot check of a network resource if you've provisioned it. There are other more complex tests you might run for larger parts of the system, right? There are some things that maybe you do want to, for a load balancer, right? You do want to maybe run an API call and test the end-to-end from load balancer all the way to server, all the way to network. Maybe that's important for you to test. But in the case of networking specifically, a lot of the testing tends to be on the integration side or end-to-end side. It's very rarely easy to test the network function with a mock or with a very small portion of it. So that's just one example of integration testing. Okay, we went through testing. Now we're going to talk about verification. I think this is the fun. Verification it's about policy from a security standpoint and compliance standpoint. There are a lot of requirements from either the way we run our business to the way we plan on securing our infrastructure components that we have to keep in mind. And not everybody is a security expert. Not everybody is a networking expert, right? So we got to sometimes divvy up the knowledge and get someone else who's more familiar with it to help us understand how to better secure our systems. So one of the ways that we think about this is using policy libraries. And we're going to show two policy approaches today. One is in Sentinel and one is in OPA. If you are in the Kubernetes space and you like Open Policy Agent, you can use that syntax and run OPA policies as well. So I'll show both flavors, and that way you can decide which one you like to use. But with policy, you can check a number of things. You can check for security group configurations, network ACLs, whatever you want to check there. You could also check whether or not there's a geographic constraint on something. So there's a number of things that you can check. At the end of the day, it's doing what I showed before from the unit testing standpoint. It's parsing that JSON plan and it's getting information from there. So the reason why you want to do it earlier than later is that maybe someone doesn't know any better and they've configured 000/0 on a security group, meaning allow all. And they don't know any better. They just wanted to do it for testing. Well, Sentinel or OPA, or basically the policy checks in Terraform Cloud, will catch that before it gets applied. So that way, from a security standpoint, you're protecting the configuration. You're making sure you're using sort of the secure configuration out of the box. And another nice part about policy, and there's a lot of other applications for this, but another nice part about Terraform Cloud specifically and policy is that you don't have to write all of these policies yourself. Like I said, sometimes you've got to divvy up the expertise to other folks who know better than you do. And in this case, I'm setting up something called a run task. So I configured Prisma Cloud, which is it has a bunch of security rules for specific cloud providers and other target platforms. And what I'll do is I'll configure what is called a run task in Terraform Cloud. What I'm doing here is I'm allowing Prisma Cloud to access Terraform Cloud. So I'm restricting my access to only seeing certain parts of Terraform Cloud in the first place. And I'll get an API token, which I will hopefully not expose on the screen. And then I'll use that to configure Prisma Cloud run tasks, the Terraform Cloud run task. So in Prisma Cloud, I'll select the workspace that I want to target. The workspace could be, cloud, it could be any of the ones that I chose. And I can choose a run stage. So I could do it after Terraform creates the plan or before Terraform generates the plan. You might want to use pre-plan in the situations where you want to double check that something is set up beforehand, right? So a run task is useful if, let's say, you set up something in your data center and you want to make sure that that has been set up first before you start to run the plan. That is important because you need those dependencies. So it's good to choose which one you want. You could do post-plan or pre-plan. I'm choosing post-plan, which means I'm doing security checks after I've created the plan. So these run tasks are pre-created by different partners. Some of them are pre-created. You can create your own run task if you want, but most of the time it's useful just to use whatever is already there from the partners. They're maintaining the run tasks and maintaining the integration. So what this looks like is that the plan will run, and then I have this post-plan pending. We'll just skip through the plan. We've all seen the plan. we see the post plan running. And what a post plan will do is that you will make an API call out to Prisma Cloud and run the scans on Terraform, on the Terraform plan that's in place. So that means you don't have to write the policies. You're using prepackaged policies from this partner who has the proper benchmarking. So if I click on Prisma Cloud and I look at the what is going on, you'll notice there's a couple interesting things that's happening, and it's found some misconfigurations or security configurations or configurations that could be more secure. So it lets me know, okay, there's public IP, I have internet access, there's EBS volumes are not encrypted, all these sorts of things that maybe from a development team or a platform team doesn't really know any better. And these are ways that you can improve, right? So there's a lot of stuff about networking, compute, storage, other configurations that are important to manage. There are a number of run tasks available, and they're not just for security. There are some for cost. There are some for, as I mentioned, some for evaluating things that are in your data center as well that you could create. So the run tasks are a structured way for you to retrieve information and defer some of these scans to another system that has expertise. Okay, so if you want to know more about run tasks, they are in the registry as well. There are a number of them available that you can check out. And if there's an integration that doesn't exist, you can always raise it. You can also write it yourself. There is a run task integration guide.
So a quick
Yep.
question there. I assume these can be scheduled once they're set up, and that you have a mechanism to pop things to, dashboards, Slacks, or other things based on content of the results that we just saw there.
Yeah, so there are notifications that you can set up, et cetera. It sort of depends on how you want to do the workflow. Some folks have the notification on the third party side. Other folks have the notifications on the Terraform Cloud side. So it sort of depends on where you want to situate them. Some run tasks, as you see in the Prisma Cloud one, you have to pop out to the Prisma Cloud. The Prisma Cloud information is not directly in Terraform Cloud. You do have to go to the third-party tool. So some folks configure the third-party tool notifications. Other folks, they configure notifications on the Terraform Cloud side to say, okay, this run failed or something. All right, so if you do not want to use a third-party tool or service that has security scanning or has these libraries for you, you can use your own, right? So sometimes there are custom policies that only you want to use or you want to define, and it's not going to be anything that's specific to an industry benchmark or something. So you can use what is the policy set again, and this time we're defining an Open Policy Agent policy set. Open Policy Agent is another way to express policy. It's I would say it's popular in the Kubernetes space, and you can use similar policies here. So if you said in your organization you're going to standardize on Open Policy Agent and the Rego language, you can do that in Terraform Cloud. So sometimes there are community libraries as well for open policy with OPA rules or OPA bundles that you want to use. And so here you can probably do the same thing. You can use those rules. So we're going to set the same thing up on our cloud workspace. I'm going to use a policy set that I've defined already using OPA and the Rego language. And I'm going to apply it to the cloud workspace. So when it runs, it's going to go through a lot of different checks. So the first is my run task, right? So you'll see the post plan pending, and then you'll see the OPA policy pending. So OPA policy will then run and do some custom policy checks that I'm looking for. In this case, I'm checking for a couple things. I'm checking for whether or not the IP address range for my Azure virtual network is in the allocated range that I expect, because maybe I've allocated that on-prem. I want to be able to route to it. Based on my setup, it has to be unique. It has to be the specific range. And I want to check that anybody who creates an Azure virtual network is in that range. This is an OPA policy that I can apply just make sure that anybody who creates a network is going to be, specifically an Azure network, is going to be in that range. So I don't have to think about it. Instead, someone else who's running this, whether it be a platform engineer, networking team, is looking at this and saying, why did it fail? Well, they now realize that the virtual network that they wanted is not in the pre-allocated range that I expect, right? So I'm going to go back and change my configuration to properly reflect that. There are other more complex ways that you can either retrieve information in OPA language, retrieve information from somewhere else and add that. So if you have either a database that stores this allocation information or otherwise, you can retrieve it from there if you want. But the OPA policy looks a little bit like this. It basically goes through the same process as Sentinel. It is parsing the JSON plan from Terraform. So the plan that I showed you before is the same plan that is going to be parsed by OPA in Terraform Cloud. So OPA and Terraform Cloud uses the same plan values, etc. So you can parse it the same way. Here, I'm using some of the functions from OPA, like the CIDR contains check. And there's some other pieces here that maybe I want to double check as well. So here I'm going to go back because I know my policy failed. I'll go back. I'll change my Azure virtual network to reflect the proper IP address range that I should be using. And then once I push, I'll push that up to Terraform Cloud and it will fix the block. And alternatively, you can always look for policy libraries. So these are sets of policies that are available on the Terraform registry. They're either aligning with certain benchmarks or otherwise. You can apply these policy sets to your workspace as well. These policy libraries, again, are an easy way for you to ensure that you have secure and compliant configuration, but you don't have to write the policies yourself. So here you can connect the same policy set. If you want to learn more, you can go check out Terraform Cloud Policy Enforcement. And with that,
I'm not sure if you mentioned it in this presentation or the previous one, but I know you said that this isn't really meant, like Terraform isn't really meant for individual devices. But I'm wondering, right? I mean, this stuff is amazing, right? I mean, it's awesome. And I've seen lots of kind of DevOps teams use it to build environments really quick. But, obviously from a networking perspective, we're very rarely, at least in my experience, working only in the cloud or only with a fabric device from another vendor. And lots of times I'm dealing with multiple devices. And that's a big part of what I look for in my automation, actually, is to avoid me having to go to all these devices one by one without having to necessarily go buy a vendor's tool to then layer something else on top of that. So I'm wondering, maybe quickly you can tell us, is that really just totally a bad idea, or is there a way to perform that with Terraform? Or, would you actually recommend a different tool in that sense? If you're really managing a bunch of disparate devices that don't have like an ACI or some kind of fabric layer above them.
Yeah, so Terraform is not, it can serve as an abstraction, but it's not, at the end of the day, standardization of protocols as well as device specifications. A lot of people ask the question to me, and I think it's a very similar thing. It's like, why can't Terraform offer me an abstraction in which I declare I can declare a network in the same exact way across all three providers, right? So the answer to that is that Terraform is not meant necessarily to provide that perfect abstraction or that single layer of abstraction, but you can get very close. So some of the ways that you might do it are provisioners. Again, last resort, absolute last resort. But if you have devices that you want to orchestrate through Terraform, but you don't really, you want to orchestrate through Terraform, and you don't want to sort of go through that separate device again, you can use a provisioner. There are other mechanisms that you can think about as well. With Terraform, various Terraform resources will allow you to get close to it. So you could use the HTTP resource, data source actually. Some folks use it for configuring devices that have an API available as well. The problem is it's really hard to capture a lot of the logic in Terraform itself. So you may find yourself still scripting a certain portion outside of Terraform, but using Terraform to run it at least. And when you do script outside of Terraform, or you do run something outside of Terraform like Ansible or any of the other tools that you might want to configure a device with, you do have to keep in mind the key requirement that you have to have is idempotency. So basically, maybe I'm saying it wrong, but you want to make sure that when you run it, when you run that script has to keep the end state, right? So a good example of this is that you shouldn't be restarting the device every time you run that script. You should maybe only restart that device if you should only restart that device if you make a change, something like that. So it's important to keep that in mind.